Great. Well, hi everyone. My name's Alex, and I'm going to be co-presenting with Cece. I'll just let Cece introduce herself once she's actually driving, but I'm calling in from Seattle, as I mentioned before. So both of us work at Miller Hall. We have two studios, one in Seattle, one in San Diego, and we have 120 or so employees. So today, this is the rough roadmap of what I wanted to present on. I wanted to do like a quick background, and then we'll go straight into a demonstration of the tool, and then discuss how to share the results once you get some sort of insight from using Tally. But before all that, I wanted to ask, for folks who are on the call, how many of you have used Tally before? And you can either like raise your Zoom hand or your real hand.
I have
Great.
not used it.
And what about like any or background with embodied carbon and life cycle assessment? I'm seeing some nods, so I might not like, I'll skip over some parts, but great. Well, thank you all for letting me know. With that, let's get into some background. This is going to be pretty rapid fire and probably like things you've heard in other venues as well. So start here. We know climate change is real. The IPCC has laid out a projection for us. We know the longer we wait, the harder it's going to be to hit those climate projections. We know the building sector is one of the largest contributors to global greenhouse gas emissions every year. Around 40% of all emissions happen to be released into the atmosphere because we like being in buildings that are warm and good. 2030 challenge responds to this by both setting targets for energy use, and now they have an embodied carbon challenge as well. And part of this challenge is that we're going to be building a lot over the next couple of decades, really, over 2.5 trillion square feet over the next 35 years. So the question is, how do we both get all of our emissions down to zero at the same time as sustaining this growth? And this is a challenge that both the World Green Building Council has taken on and AIA. They've both released statements saying that our industry is up to the challenge, and we recognize the time value of what we do today matters more than ever. And there's a Tally logo because that's what we're going to be talking about. So embodied carbon represents greenhouse gas emissions in general. It's not just the carbon. So it also includes things like methane, also known as natural gas. So it represents greenhouse gas emissions that are released during processes that are associated with building materials. So we're not talking about energy or electricity or the grid today so much. We will be talking about materials and how they get extracted, how they get manufactured, processed, transported, installed on site, removed, replaced, deconstructed, demolished, disposed of, like all of the emissions that happen in order to make these material related processes go through is under the umbrella of embodied carbon. How do we count it? To count embodied carbon, we use a process called life cycle assessment, or LCA. LCA is essentially, it's like a systematic way to calculate the total environmental impact of every product based on quantified emissions in each process to make that product. So what you're seeing on the little diagram to the right is there's, the earth, and then there's a little timeline spinning around it from material extraction to production, construction, use, etc. At all of those stages, we are taking something out of the earth, like we're mining, and we are putting something back into the earth, like we're releasing greenhouse gases. So the point is, life cycle assessment just is a huge balance sheet of like everything we've taken out and everything that we've put back out, broken out by life cycle stage as the product goes through its entire life cycle, from extraction to eventual demolition, disposal, or recycling. And the core idea is, it's a pretty simple equation. You get the inventory, the amount of stuff that you're using. It's the estimate of quantities of materials in a building. You then multiply it by the impact to make that material. This is an estimate of the environmental impact for each material and process. After you do that for every single material in a building, you can get a cumulative total impact for the building. So a little example, like, you're using 100 kilograms of steel, each kilogram of steel requires 0.43 kilograms of CO2 equivalent being released into the atmosphere. Now you have the total impact of manufacturing all the steel that you need. So you all are familiar with buildings and you know they're much more complex than this equation because we have a lot of stuff and a lot of different stuff that interacts with each other, right? So that's kind of where tally comes in. The thing that tally does to simplify this equation for you is, first of all, it pulls information from Revit to aggregate a list of material quantities. So just like you do material takeoffs for costing, Tally has the capacity to do material takeoffs for environmental impact costing. So it saves you some time by doing that. The other important part of it is we don't readily have the impact table like memorized in our heads. You know, this is all coming from a pretty complex database of actual manufacturers who have to go out and measure how much CO2 gets emitted during a particular industrial process. What Tally does is it lets a user of the software, like architects or engineers, to associate materials with environmental impacts from a database called GABI. So essentially, all of the manufacturers' know-how about what it takes to make something has been collected by a GABI operated by Sphera. Tally plugs into that database and lets you say, like, yes, this steel is in fact steel, and I know that this is the impact that I would like to use. And finally, the software aggregates a cumulative report to pull it all together. So you don't have to keep like a huge Excel table of here's all the steel, all the concrete. It will allow you to take a look at the entire system of building materials interacting with one another. So quickfire Tally can and Tally can't. Tally can give you an overview of the environmental impacts from all those life cycle stages that I mentioned before. It can work on any scale. You can be looking at like a little chunk of wall, or you could be looking at a multi-building campus. As long as it's in Revit, you're good to go. It can pull from large and third-party verified background data set. That's the GABI set that I just mentioned, and let you compare discrete options. So if you're like at a crossroads in your design and you could go metal panel or GFRC, you'll get like the answer to which one is more environmentally impactful in an expedient manner. And Tally as a software can also be used as documentation for the materials and resources credit, the building lifecycle impact reduction credit under LEED V4. Under V4.1, you just get a credit for running any sort of lifecycle assessment. You don't even have to, go into the reduction land. So as long as you've used Tally and produced a report, that's a LEED point. Unfortunately, it's not like a super powerful software, and there are some things that it can't do. It can't work without Revit. It can't clean up your model for you. So there are, if your work sets and your assemblies need love, that's not something that can happen in Tally. That's a good BIM practice. It can't really account for demolition scope. So if you're doing renovation and taking out a bunch of walls, it's hard to capture the impact of taking out a bunch of walls. And it also has scope limitations. So generic models, MEP, site work, or landscape components are not addressed by this software yet. It primarily focuses on structural components, envelope, and architectural interiors. I also forgot to put this on the list, but no FFE either yet. It can't tell you materials performance characteristics, so things like acoustic rating or conductivity, cost, or availability in your market. So what I mean by that is like it's a bit seductive at first to think like, oh, I'm going to compare these two materials and I'll know which one to pick. Of course, there are so many other parameters that go into material selection, like does it work for your design in other ways besides embodied carbon? Is it even sold in your market? Is it within the project budget? Like all of these exercises happen outside of Tally, but they are related. And it won't let you plug in your own environmental impact factors. So I told you about the database. You can't like go haywire and say, I know that a kilograms of steel is actually 0.6 kilograms of CO2 equivalent to a kilogram produced. It won't give you that capability. So the general idea is we're trying to get away from the typical workflow and go into the Tally workflow. The typical workflow in this diagram above is from schematic design to design development to CDs. We run a report at the end, we report, and we're done. The idea is that this tool is live within Revit and is live during your design process. So it becomes iterative as you move from the different design stages to the next. So with that, I kind of hyped up Tally and gave you some context, but Cece is going to take over and show you what the actual interface looks like for a project that we're working on.
All right. Can everyone see my Revit screen? Great. Let me see if I can move this toolbar out of the way. Okay, so when you open up Revit, a typical 3D view would look like this. This is a project that we have been working on. It's a fire station for San Diego and Torrey Pines area. One of the first steps you're going to do before you even get into Tally is I like to copy a new view, a Tally 3D view. And you're going to go into your work sharing display settings. And I have the work sets turned on. So that allows me to see what color each work set is. For this project, core and shell is purple, structural is green. We have interiors as blue. Those are the primary colors you're going to see here. And by doing this, you can see where there might be some overlap if there maybe is two materials over each other. So this is a good way to make sure that you're not counting embodied carbon twice by having two different walls overlapping each other. Another thing you'll want to do is in your new Tally view that you created, you can go to view graphics and make sure to turn off anything that Tally isn't going to be able to view. So you can kind of have a screen that's clean and only showing what you're working on in Tally. So Tally can view roofs, ramps, and structural components. So that's all fine. But Tally can't do electrical. So you're going to want to hide those elements like so, and do that for all of the different disciplines here.
So the reason you're trying to do this is essentially setting the scope of your study, what's going to be actually included when you run it. This is a visual cue to remind you like, oh, the pavement is not part of it.
Exactly. And then an example of two materials going on top of each other is here. We have a structural deck and an interior finish overlapping each other. So those are the things you're going to want to look for, these kind of like weirdly shaded areas where two components are overlapping. All right. Alex, anything else in
No, I think let's get into the, so Tally is an add-in. So it shows up in your add-ins ribbon.
There. Okay, so I already clicked on it. So this is the first pop-up that's going to happen, and you're going to go up to the top left. There's different options: full building study, design option comparison, define template file. We primarily work with the full building study. These here are all the categories that Tally can collect data on. So if you're not seeing it here, then it's not going to be part of the Tally calculations. So ceilings, curtain wall, mullions, curtain panels, doors, floors, roofs, stair railings, structural components, walls, and windows. So Tally's going to read all the work sets that you have. You're going to want to click on, that's your Revit file name, and you're going to want to click off areas that aren't part of what Tally is going to be viewing. And a quick mention here is it's a good practice to have a Tally do not use option in your work sets within Revit, and that allows you, if you know that there's two overlapping elements, you could hide one of them. So Tally's only calculating it once, and you'd hide it by just moving that element into the do not use Tally work set. And then here you're going to click on new construction. And then right now, the only option for phase demolition is none. As we mentioned earlier in the presentation, Alex was saying how it can't calculate demolition. So for remodels, it's not an option yet. So once you click on everything, see how I didn't click on this one, it won't let you go to the next section. So make sure you click on all the components that you want to look at. For ease of upload, we're just going to look at walls today, or actually I can upload all of them. And then the last thing to note here is that if you have any linked models, they're all going to be down here as well. And you can include like your structural mostly structural. So you could link those in as well. So for the next stage, it's going to take a couple seconds to upload all the information, and then you're going to notice some yellow and green circles, and then there's these arrows. So when you first do it, I've already populated a good amount of information in this file. All these circles are going to be grayed out. And then once you put all the required information, it will turn green. And if, for example, this one's yellow because this one door here is missing information for this component of it. So once you put in that information, this bubble will turn green, and so will this one. And that's how you can kind of quickly check to see if all the information is put into your tally model. If you were to change something in Revit, you can quickly just go to this refresh button here, press that, and it will update the components that you defined in your scope here. So yeah, you can always go back, redefine your scope, and you can refresh on the top ribbon there. And to kind of walk you through defining a material, we will go into walls, for example. Let's see here.
So when Cece says define a material, that's like associating the environmental impact data to the thing in Revit, the quantity in Revit. You're essentially like manually establishing a link telling Tally, yes, this layer of gypsum wallboard is gypsum wallboard, and take on the environmental impact of manufacturing gypsum wallboard.
All right, so I'm going to use, let's say, this one here. Let me close these guys. So,
go ahead.
Yeah, you sure?
I just wanted to mention that the hierarchy of how information is displayed is up on this ribbon here. So when Cece is like, going through and actually expanding, she's going from model to Revit category to each family to then the material inside the family.
Correct. So, pull my bar back. So yeah, now we're in the material within this fur wall, or let's do this one. It doesn't really matter. Yeah, probably a better one. Okay, so now we're in this this 1 hour wall. So let's pretend this one was gray, and we're going to right click on it and edit definition. So we're gonna search through this menu here and try and find what we're looking for, which is the type X gypsum board. When it's actually, I'm going to clear the definition so we can do it from scratch. So if you made a mistake and you put the wrong definition in, you can just gray it out. You can also, if you know that isn't an actual component, you can make it a dummy material. So then that doesn't show up. But ideally with Revit practices, you want to have your model, your wall family modeled correctly. So you don't really use this dummy option, material dummy option as much, which is good. So we're looking for type X gypsum board. We're going to go to finishes, and we're going to go to plaster. wallboard, gypsum, apply. So from here, they're all red and you need to fill them all out. We'll go to type X fire rated, and you can either do the default setting, which is saying that this gypsum board is going to be replaced within 30 years, or set it to building life. And then you have two different takeoff methods, either volume, it's calculating the volume of that layer in your model, in your wall assembly, or by area. And by area, you would specify that this is 5/8 gyp. And then you further go down and you'd give it a finish. They have several options: exterior, interior, silicone based, acrylic based, while covering if it had wallpaper on it. And then the last thing is if it has, the gypsum board has foil. So you're gonna fill in the required information and then press save. And now all that information is on the bottom of the right hand underneath your material. So you'll notice on the right, when you click on a different layer of the family or material within the family, it highlights what that component is. Let's do this one. So here we went to steel, we went into stud, C-channel, apply. So we picked galvanized steel here. Spacing 3 5/8. Either in this one, you can either do length or spacing. And then you put the type of stud it is, and then the spacing here. So that's another way. So length, volume, area, those are all different ways that you can consolidate information. If, let's say, there was insulation within that wall, you would pick this option here. And then that one allows you to add an insulation type as well.
Are there any questions about this point? I think maybe let's take a brief break before going into like, what do you actually get out of the software? Are there questions about what you're seeing on the screen, or how to operate it, what the point is?
I think seeing an actual demonstration is awesome. I've heard of Tally. I've seen it before, but I've never used it, and I've never seen a live demonstration. So running through the steps is really helpful. I'm wondering the materials that, since we're looking at wall assembly, if you have a wall type and it has the assembly, does it default to the characteristics of that, or do you have to go in and select each one, like you just did, or was that just a demonstration to show if you had to?
So when this model, I've already input all the information, but it's all these circles here are going to be grayed out when you first open up Tally. It's going to say this information here, so it gives you a clue as to what you're looking for, because it's reading your assembly that you created in Revit, but it doesn't have gypsum programmed into it yet. You have to manually go through each bubble and select the proper material.
Yeah, but Luke, there is a workaround if you use a lot of the same type of assembly across projects. If you have a Revit template file, and within a Revit template file for your office, those layers are defined using Tally. Anyone who uses your template file to create a new project will have those predefined layers.
Right. Awesome.
And then
that makes sense. Thank you.
Yeah. Another quick workaround, especially for walls, is if you know that the same type of wall stud is used in different wall assemblies, you can underneath definition, instead of finding it again, you can just copy definition from. So that's a quick way, and then it will auto-populate all of those locations. So
It's
Cool.
also a quick way
Thank you.
to enforce our BIM standards on our project teams and say, yes,
yes,
if your wall types are consistent and your Revit materials are named the same thing, there's
Yeah.
value that comes out of that.
So we really want to not have a messy model, because when it comes to tally, it's a complete headache. I've been in example projects where there's like, I don't know, 20, 40 different wall assemblies. So to have a clean model like this is super helpful. Anything else that I should go over, Alex, before we talk about how you extrapolate the data? We have about 15 minutes.
No, I think,
Hi, this is Ione. Can you hear me?
yeah,
And my apologies, I came in late, and if you've already answered this, just say watch the recording, because I appreciate that you guys recorded this. How do you handle existing building materials towards crediting it for energy savings? You know, in terms of embedded existing carbon.
Ione, I think you're getting into a really good and complicated question that would merit like a whole other discussion on its own. But there are mechanisms in Tally to say this is an existing material that I am retaining in the design and don't plan on doing anything with it. It's essentially like CC's showing right now, there's a way to toggle that this JIP might be existing, and then you wouldn't take on the environmental burden of manufacturing it since it's already been made.
Okay, but do you get any environmental credit for saving it?
Yeah, because you don't take on the burden of making it again.
Okay, but still enclosing the volume. All right, I get it. Thank you.
Yeah, no problem. Well, I think I'm gonna hop over to like the next little bit of this, which is what do you get out once all of your nice green lights are encouraging and green.
Yeah.
So do you mind if I
Yeah.
take over screen share again?
Yeah, and then that last step that she's going through is this save report button here. So you're going to fill out the information, and it's going to either export it to EC3, or it can also create a PDF and Excel file, and that's what Alex will be talking about now.
Thanks.
Mhm.
Okay, so working with Tally is a process that will make you very intimately familiar with your project, because you both need to have a view of the materials. What do I go to define next? You need to know where it actually is in the model and what it's supposed to represent. Look at your specs and your drawings to understand what did we actually use or install, and keep track of all the substitutions that you make along the way. Because while the database is robust, there will always be bespoke items that are difficult to define. And we'll try to, work with manufacturers to understand it in the best case scenario, or try to substitute it with the closest available thing. So sharing the results. This is the workflow that we use at Miller Hull, but it's not like the workflow. There's lots of ways to work around with Tally. So I'm hoping to showcase 3 options. We go from Revit to Tally, then export it to Excel, and then do some data prep and visualization using Tableau. But there are lots of different tools for embodied carbon reductions besides, Tally. There's also EC3 and all these others that I will share, I think, in a PDF once the presentation is over. So I think I'm going to talk about 3 options on how to access your results, and I will go into an example PDF, an example Excel report, and then an example Tableau report with the same question. So the Torrey Pines Fire Station that CC just showed, let's say I want to find out what is the top, where is the top impact coming from, right? What is the one material that I should focus on to get the biggest bang for my buck? So in the PDF, there's a full building summary, and then there will always be information about environmental impact totals on the front page, as well as environmental impacts per unit area. So straight away, I can see if global warming is what I'm interested in. The stage that's the most important to pay attention to out of all of these stages is the product stage. So not so much stuff being installed or used. I need to find out what is heavy to manufacture. There are then a few pie charts and bar charts that are available to you. So this first one is results by life cycle stage, confirming what I just said, that 82% of the global warming potential is coming during the product stage. But there are also these charts itemizing your results by division, and then further by Revit family. So this chart is breaking out the global warming potential by division. So looking at this for the Torrey Pines Fire Station that CC shared, there are two pieces of the pie that stand out. It's this pink one, so Division 7, thermal and moisture protection, something's really throwing me, and Division 3, concrete. I know you are probably familiar already that concrete is oftentimes one of the top perpetrators because of its reliance on cement. So this report, you just interact with it in this way. You can look at all of these different pie charts and bar charts. There are a few ways that Tally spits out results. It will furthermore tell you that, okay, like 47% is coming from roofs. Roofs don't have a whole ton of concrete, but they do have like thermal and moisture protection stuff in them. So that's another clue to me that I need to look to my roof assembly to understand where the impact is really coming from. And furthermore, like this is itemizing per Revit family. So there's, and this is a little bit hard to read here, but if I look for the legend for this largest bar, this 38% of global warming potential is coming from some family. That's my roof 1, insulation on metal deck with seam. So that's one way to get at your results, is to parse through the report, look at the bar charts, look at the pie charts, and then you'll have valuable information to bring back to your design team and say, can we investigate a different type of roof 1 assembly, because that's the biggest deal for this particular project. Another way to interact with the results is to look at the Excel that Tally provides. So every time you export a study, you also will get an Excel result that comes with multiple tabs. This is the same information that's feeding the PDF report. There are multiple tables to look at the environmental impact of your model. There's just breaking it out by Revit model. So it looks like in this case, I had an S Revit model, so some structural and then architectural. So between structural and architectural, it's about like 2/3 of the impact is coming in the architectural model and about 1/3 coming from structural. Look at the breakout. Let's try to do the same exact thing here with the division. So there are a few tables here, and they're broken out to different levels of detail. They are pivot tables, so if anyone wants to like really go deep, you can also use this field list button to go even farther. But you don't have to do that to get meaningful outputs. So let's say, let's ask the question again, what is the top impact of building this fire station? I'm gonna go straight to division to try and narrow in where the impact might be coming from. So in this table, when I look at the sum of global warming potential column, I can see straight away that the thermal and moisture protection division is the highest. And then there are a few tabs here that are division further breakdowns. So like within each division, which Tally entry is it that is the most impactful? So this is the breakdown that we're looking at right now. So I know I'm looking for something in Division 7. I'll go over to the global warming potential column here and scan across. You could also, apply some conditioning formatting in Excel. But right now, for lack of time, I know that this by far is the biggest number, right? It's the XPS. The XPS in our project is the top perpetrating material. So another way to get at the same kind of question. And the last option is, so what we're looking at right now is like a dashboard that we custom built at Miller Hull using Tableau. The main reason that it exists is because it's nice and like it's a nice visual summary, but it also helps us do quality assurance faster than working with the Excel sheet and the PDF. But let's go to the same, give me a second. Something had to go wrong during like a 2/3 demonstration type demonstration. So this is it. Anyway, the point is that it's a dashboard that you can click around and then like try to understand what the heck is going on in your model. And it will give you the same exact answer that it's the XPS in roof 1, just quicker. So with that, I think let's open it up to some Q&A. I'm going to tab back over to the presentation. I put in some sample questions and answers in here. These are all things that we love to talk about. But yeah, open the floor.
So I have an initial question. One, thank you so much for presenting and showing how this actually works. It's very informative, so thank you. So I noticed at least there's a lot of data and input required. So I can see this being a really useful tool as you get into design development and CDs. But as you're starting in schematic design and you don't know, the spacing of studs and all of the materials and the assemblies, how do you guys use Tally in those initial phases when you don't have all the data?
That's a great question. So I think the best way that I've seen is modeling mockups. Like instead of doing a full-on building analysis, when during schematic design, you're thinking about like wall types or roof types, just model like a square foot of that assembly, like think through 1 square foot and compare it to a square foot of the alternate. So there are ways to use the tool that aren't just taking the entire building and tallying it all. Cece, do you want to add anything?
Yeah, I've used it also where we're trying to compare to 2 different types of walls within a building. So even if you don't know the stud spacing, you can just do a generic one. But we were comparing rammed earth versus CMU block just to see what the carbon emission was. So yeah, we didn't go into the roof, we didn't go do any of that kind of stuff, but we just wanted a quick takeaway what those differences would be. So yeah, it's okay to use kind of a generic one at first before you kind of finalized everything with structural, but it's a powerful enough tool that you can get those differences just by doing quick studies like that.
And I got my little tool working again.
Nice.
Oh shoot, did I disconnect?
Yeah, I don't see a screen.
Okay, well, I'm back. Zoom just like crashed and then uncrashed again.
Oh no.
But for Torrey Pines, like basically this bar chart is telling me the top materials by global warming potential. XPS jumps to the front. Out of like these pie charts to the right, I know like insulation is 35% of the total impact in the project. Within insulation, it's definitely the XPS. Within the XPS, it's definitely R1, even though we use a little bit of it in W2 and in W4.
I have
So
a
that was
question.
kind of a divert. Yeah, go ahead.
If it's a good place, like Michael stated, thanks. This presentation was fantastic. I've never used Tally, but I've always wanted to. In reviewing, that printout, that analysis, a couple things come to mind. Like when you look at a pie chart, it's always going to be 100%. So if like the steel and the glass and the concrete all start to come down, then the XPS looks like it gets really big, but it'd be nice if like an EUI, you could compare it to a comparable like baseline project. So, maybe the XPS is totally fine. And that's within the normal, global warming potential for that type of project. But it looks like it's huge because the other ones are now, reduced.
Yeah, you're getting
mean?
at a really good point about these studies and like what is total impact versus normalized impact. There is one way to normalize it, and that is just like EUI to divide by project area. So in the PDF report, this is reported as global warming per meter squared instead of
So that's
square
like
foot.
EUI, yeah.
Yeah, so it's a little like EUI. So, if you've seen enough of these, you know that like 600 is kind of on the high side.
Okay, got it.
But, there's ways to access that data, and that's a really good point.
Because if you brought that XPS, if you swapped it out for something else, it would just make all the other ones look like they're doing worse. You know what I mean?
Yeah, so I guess like a research question would be, in projects at our office that use XPS, what percent contribution do we expect from
Yeah,
the
like the
XPS?
baseline. But I mean, that would be a big effort, you know, because that's like material by material or division by division. Anyway, that's just one thing that's sort of like a
Yeah, that would
particular
be
thing.
interesting to follow up.
We work on pretty big projects. We have a couple hospitals now, and it's like so daunting to think about starting to use Tally for, you know, a big hospital that's in CDs. And is there any way that like we can get 80% of the, you know, results with much less of the input? Like, is
I
there
think
any
start
low
with your
hanging
structure. Start with your
Mhm.
structure. And honestly, like a clean big model will still take less
I'm sure
time
it's
than a
not
dirty
clean.
small model. Because even if it's like a little single family residence and there's a bunch of like
Mhm.
generic models that aren't actually categorized properly, that will anyway. Bigness of project is not the time determiner. It's the rigor of,
Cleanliness.
rigor of your work sets and
Well,
your
assume it's
type.
big and messy.
Start with your structure first.
Okay. All right. So if we did structure and, you know, presumably the facade, and left out the interiors, you know, what percent of the overall picture would be, you know, do you think that we'd actually be looking at? Is it 75%? Like,
You know, that's a good question. I think based on like the data that we have, you'd probably be looking at more than half of the results. The
Okay.
issue is like we have some blind spots still. Like we know, for example, we use really really high global warming potential refrigerants in mechanical systems, but
Yeah, right,
those aren't
right.
included in the study, so they don't make their way into the pie chart. Since our tools right now, like, hammer nail analogy, like our hammer is really good at telling us about structural impacts and enclosure and interiors. When we just limited to these three, then structure usually accounts for like more than half, 3/4 of the whole
Okay.
thing. And it's also easier to specify because all the interiors, it's hard to like chase it down in your technical sections, but when you're hitting like all concrete or all hot rolled steel on the project, that's higher
Yeah.
impact. But I do want to, caveat, we still have blind spots like mechanical systems that might blow that out of the water. So
I mean, that's useful right there. So thank you.
yeah. Well, I'm sorry, but I have to actually jump to another call, but this was really nice. So thanks all for setting this up.
Yeah, thank you both. Thanks, Michael.
Yeah, feel free to reach out with
And
any
Lee.
questions. I'll post my email in the chat.